Hello. Gavaskar, can you speak something? YouTube and the site also. Okay. The voice I have to check because something is happening with the voice. I'm just checking it out. Testing. Hello. No. Uh, yeah. Yeah. Input is audible. Output I have to see. Maybe the mic. Yeah. Yeah.
Okay, I think.
Are you able to hear your voice?
Yeah, yeah,
And are you able to hear my voice?
yeah, it's audible.
Okay. Cool then.
Yeah,
Yeah. Input is audible. Output I have to see. Okay. Yeah, I can hear everything correct.
okay.
Okay, so we are all set. We are live, and we just waiting for.
Okay, I think.
Yeah. To hear your voice.
Yes, yeah, yeah.
Are you able to? Is coming on the site also? Can you check?
Okay.
All set. We are live.
Okay, I think. Yes, yeah, yeah.
Is coming on the site also?
Yeah.
Hello everybody. Blockchain has been here for decades, and one of the best features of blockchain.
Yeah, I can see. It's there, right? So it's already on live on the site also and everywhere. So it's all okay. Cool. So let's start in another 6 minutes. Buck.
Sounds good.
Yeah. And we already have 11 people join. Hi Hariharan. Hi Pranja. Hi David. You can see. Yeah. Hi Krishnati. Hi Anand. Hi Bhavi. 6 minutes.
Good.
Already have 11 people join. Okay, so if you have any question, you can put it on the chat window. Those who are online, they can put it on the YouTube channel in the comment box, or those who are through LinkedIn, they can put it on their LinkedIn channel, and then definitely we'll be able to answer that out. Hi. Um, so that's how it will be. We'll start sharp at 9 p.m. I will hand over to Buck at the maximum at 9:03 or 9:04. So it's
For
just
those of
5 minutes.
you in other time zones, that's 11:30 Eastern Standard Time, US.
Yes, so it's 11:30 EST,
About
and you
4 minutes.
yeah, yeah, and here is 9 p.m. and it's 3:30 p.m. GMT. So we actually the way this concept came is like almost 2 years back. So most of the techies who are actually directly working in the industry, they never get time to spend on their career development, and they
Right.
are not able to attend any session and event in the weekdays because they have so much to work. And here in India, it's like it's overwhelming. Now with COVID, everywhere it's like everyone is working extra hours. So
Yes.
so we thought that let's try with something when there's a breakfast time or a coffee time or a dinner time, or something when people can actually come and at least at least here. So we also start a radio, so in parallel. Currently it's stopped, but we are trying to soon start it again. So all this recording also continuously play on the radio. So when you are like driving or doing something, you can go to Southcast, tune into our channel, and all this recording will continuously be playing. So that was happening last year. We'll restart it again because we see now people are again trying to shift to radio. So
Right.
because everyone was at home, so we stopped it and we started moving into the web-based or the video-based one. But,
Right.
So
Right.
this all recording gets on continuously replaying 24 hours.
Very nice.
Yes. So and this has actually helped us. I think now almost 10,000 plus people are connected, and they are mostly hardcore technologists. They are mostly working in the industry, and these are those people who don't have much time.
Right.
Other than work and the family, they don't have much time. So only their dinner time they can spend a little. At least they can listen, right? So if they can just
Right.
stream
Exactly.
it on their YouTube or something, and they can just simply listen. At least they will get something, right? So and then they can come
That's
back
right.
to give exam, get certificate, and it's a quick certificate, right? So like and people have started recognizing this, so it's good. And we also try to help people by like if they share it, bring up more people. So we give a lot of reward, community reward to just help them and encourage them to do such good thing for all.
Right.
Yeah. So
And
yes.
and you'll see me looking around the monitor here. I've got two monitors, so I've got one
Yes.
here and one here. So when
Yeah.
you see my eyes going different ways, that's what I'm doing. Some people are like, "What are you looking at?"
Yeah. And
Yeah.
I have a 34-inch monitor. I just took away all those 2 monitor and just bought another one, which LG has a 34-inch wide monitor, and that's a pretty big on my screen. So it's almost eat all the space.
All right.
Okay, we're just 2 minutes away to start.
Yep. I see my good friend David Cease has also joined us from the US, so that's
Hello.
wonderful. This is a Saturday at lunchtime. That's quite a commitment to make to your.
I will unmute him to say hi. Hi, David.
Everybody, glad
Hello.
to be a part of this.
Awesome. Well, it's good to see everyone here, and it's great that you're taking time out of your weekend to improve your career. That's an important thing.
Yeah, just for half an hour. It's not so much.
Yeah. Well, we're a full hour, correct?
Yes, full hour. And one of the beauty of the WebEx is like we choose WebEx because like you can play it like audio. Like if you download it on your phone, you can just enable audio only option, and it will simply play it on your headphone. You don't even have to watch
Okay.
on the phone or the screen.
Oh,
Okay,
awesome.
so just 1 minute away to start with. I believe everyone is able to see my screen. And Gavaskar, you can start the recording now. Cool, thank you. So as usual, hello everybody, and just waiting for the 9 p.m. to start with. We're still waiting for a few more people to join, but I will start anyway because Buck has a lot to cover and I will not take much of your time. So I'll start with the session itself. So actually I connected with Anna, and then Anna suggested me to connect with Buck, and his name is like there's another person, right? So Jason Anderson, right? He is uh, who has done a lot of work on the blockchain in Microsoft. And then Buck suggested that okay, I will help you guys to understand SQL Ledger at length and at depth. And then I requested him, and he like it was like an honor to get him here, and it's like an honor to get him here. Was acceptance was a big thing, getting his time was a big thing, and now he's here. So welcome, Buck. And so he's an applied data scientist, and I will talk about more. And he's the part of Azure Data Services team at Microsoft. You can directly listen to the recording and everything at fifthir.com/buck. I will go to the next slide. And so for audiences who are there on the stream, they can directly go on our YouTube multi-cloud for you page. They can hear the streaming. They can go to fifthir.com/buck. the streaming would be live at this point of time, and you should be here to see it. You can chat. I have a team member sitting here. You can chat with this Facebook channel, Facebook Messenger. Obviously, it's a bot kind of thing, but someone will reply and will pass the message to Buck, your questions. And also you can comment on YouTube. Uh, as fifth IR is there now, it's almost 1.5 year and plus. The way we started the session, the way we build a whole platform to enable everybody around the world to learn a lot in their ledger. So it's more around this. This is strictly meant for people either who are starting in the technology or who are the expert in technology and they are trying to uh, 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 learn new things and new ideas and new technology that is evolving up, and those are actually supporting the transformation and transition towards fifth industrial revolution. So obviously we are into almost fourth industrial revolution, and you will see because of the transition and the speed that COVID and the changes has begun with the time. Within no time we will be transitioning, and we are already transition has started. So therefore you are seeing a lot of changes in the world coming up. And that's where fifth industrial revolution is. We are just trying to focus on all the technologies which will help you transition fast to fifth industrial revolution. And it's not just the technology, there's an emotional challenge. There are a lot of other challenges to cover up into different sessions, bringing experts across the globe and trying to amalgamate here to help you out. And you see this, the impact within a year. Like we are more focused into India. Like more people join us from India, China, and most of the Asian countries. It's not just that people from US, North America, South America, Africa, and all of the part of the world join here on different sessions. Obviously, the sessions were not so fast at this point of time because of there was a lot of devastating uh, pass in this 2-3 months because of the corona here in India. But we have again started it after 2 months of a break. Obviously, the session keeps on happening by on the voluntary basis by different people, professors from universities and experts from different places. But the major event was almost stopped for 2 months. And this is like we focus on different agile session. Like these are very pretty much agile session to help you as a T-SEP. And we have developed courses with the expert also to gain more experience around a specific thing in more to develop you as a more like a T-SEP individual. We are placed in US, India, and UK. And these are all the people who have blessed us, I would say. There are almost 4 generations of transformation experts, and starting with Bill Inman, now Buck is here, uh, uh, Suresh Kandula, Jeff Barr, who is the chief evangelist of AWS, uh, and and hundred of people. These are just the images of few people, and there are hundred of people who are there on the site. You can go there, find out their session, even get yourself acknowledged and learn on different topics. It's very easy to search and use, and you can directly search on fifth IR with a topic on Google also. So about Buck, so he has 40 years of experience, and he is in the industry since 1981 and much before that. But whatever we have found on LinkedIn, that's what we are putting up. He started his career with United States Air Force. Then he moved to NASA. He has been into different roles, manager in different companies, and he worked as a consultant. He works as an architect. He's also a teacher, and he's like a lifetime teacher now. I've seen a lot of his videos, and they are so inspiring, and so like I've learned a lot of things from him. He's applied data scientist at this point of time with Azure Data Services team at Microsoft, and he talks about SQL Server databases. I think for long, because I'm hearing him for almost 5, 7, or more than that on this topic, similar to it. This is the hosting team. I am the founder, Anjani Kumar. Dheeraj Singh, he is he's a volunteer evangelist, and he is like a founding member in terms of as a voluntary role. He does a lot of evangelism activity in US. Gavaskares, he's our delivery director, and I think if you go on his LinkedIn profile, there are 300 or more certificates that he has done. He leads our fifth IR and training and this evangelism team in the background, how this event and session are hosted. We have with us our founders Rsa Singh and Bhaskar Tripathi. They're mostly they follow different, they have a different role. And then we have teammate Abhishek Gaurav, Dhruv Gupta, Paranjay, Soumya Pranjal, and then We have volunteered by evangelists worldwide, like Jack Garg, Abhishek Mishra, Deepak Singh, Priyas, Nilosima, Harbaks, Suresh Kandula, Anna Hoffman, and almost 10,000 plus of supporters across the globe who help us as and when we require and as and when request them to volunteer us for an event. For this session, you have a certificate after a quiz. You can go on the 5th/Buck page, click this quiz icon, and then you will be able to take into an exam site. You can give 5-question exam, and once the exam is there, just 60% is the mark, and you can try as much time as you can. And then you will automatically, your certificate will be sent into email also. And if you just refresh this page after 4 or 5 minutes, it will also be there. Like here, it says 1 free certificate to claim. It will say 1 free certificate to download. In this session, because quiz is there, as per our normal form, we usually pass the speaker code. You will not pass the speaker code. You will have to pass the exam. And you can try as much time as you can. So over to Buck.
Okay, well, thank you very much. Hello, everyone. Thank you. I'm going to look over here while I share out my screen. And I click the share button. We use so many platforms when I speak that sometimes I've got to make sure. So hopefully we've got a recording going, it says. So we'll hopefully get that started. And here we are. So welcome. My name is Buck Woody. Thanks for that very kind introduction. That was I'm almost can't wait to see how well I'm going to do with that kind of introduction. I've been working on a technology here in the SQL Ledger area. So I'm on the Azure data team, and I work with all of the database platforms that Microsoft has, both in the cloud in Azure and on premises. So we're going to talk a little bit about this today, and I have a background in security as well. And so when I first heard about blockchain, I thought, wow, I should get into this because, as you know, there's a great deal of hype around the blockchain. There's a great deal of excitement around blockchain. And the issue is a lot of people get excited about things and they don't exactly know what it is. And so as I begin to see this, I saw $21 billion. And this is a long time ago. This is back in 2020. My goodness, it's much bigger now. And even more so, 90% of the projects that are started aren't really set to go to blockchain. So for those of you sharing your camera, Nitin, if you want to, you can go ahead and just stop sharing your camera because you don't really need to share it out unless you just want to. You're welcome to block your camera or not share. That is up to you. But the idea is that a lot of people feel like they're not sure about what blockchain is. And in fact, the hype is so big around blockchain that I saw this article. This is amazing. There was a company, it's called Online PLC. It's in the United Kingdom, and they just changed their name to Online Blockchain PLC. And by doing that, they had a 394% stock increase. So all you have to do is just put blockchain in your name and you'll make a lot of money. Nobody knows what it is. Nobody knows what to do with it. It's just put the word blockchain in there. So that's crazy. It just makes no sense whatsoever. By the way, the company did not implement blockchain at all. They didn't do anything with blockchain. They just put it in their name and up it went. Well, that becomes a bit of an issue, right? So where does all this come from? Well, it comes from the fact that the word itself is immature. And whenever we have something that's immature, we haven't really defined all the terms. Do you remember big data or business intelligence or other terms that were new? Everybody misimplied them. And then as time went on, we now understand more about what big data really is and what business intelligence really is. And so it settles down. And we need to do the same thing with blockchain. Now, I'm a very simple person. I have to break things down so that I understand them better. And so as I was doing that and taking notes and learning myself, I created the slide deck that you're about to see. It kind of helps me understand. So I hope it helps you understand. So we'll go through this. At the very end, I'll address some questions if we have time for that. I'm going to try to show you a lot of references and code all of the things I'm showing you are publicly available. There's nothing private in any of this that I'm showing. Nothing you can't get to for free. So let's talk about blockchain. Well, there's blockchain and there's blockchain and there's blockchain. So let's detangle it a bit. Most of us heard about blockchain, or maybe you are just hearing about blockchain through something called Bitcoin. And we may have heard of a Bitcoin and cyber currency and NFTs, non-fungible tokens, and smart contracts, and all these words are swirling around. What in the world does it mean? Well, when some people talk about blockchain, they mean the process and they're making it equal with Bitcoin. That's what they're doing. So then we need to ask ourselves, okay, what's a Bitcoin? So let's talk about blockchain, the process first. Now we'll start with the regular money, the money we know about, right? And so the money we know about, I'm sure you had this happen. You went to go outside, and your mother, when you were little, said, "Go in there and clean your room." And you said, "But why?" And your mother said, "Because I said so." And that is a word that we use for that is called fiat. It's from Old Latin and Greek, and it means basically because I said so. That's literally what that means, just because I said so. And so fiat, that's what we're talking about here. And most of us are aware of that, right? When I go and I try to spend $1 somewhere, I want to give somebody $1. I give it to someone and they take the dollar because the government says it's worth $1. Now, in the US currency, it has not been backed up by anything for many, many, many years. It's not been backed up. And so it's just worth $1 because the government says it's worth $1. I go down to the store and I give them $1 for the loaf of bread that I'm buying. And they turn around and they take it because the government says that it can. And then they give it to their employees, probably much less of the dollar to their employees. And the employees take it because the government says it's worth $1. And so everybody sort of trusts everybody. But the idea of the money we use and the money you use in your country is it's backed up by a government. It's backed up by a body. We can have it as a physical asset, little pieces of paper that look like $1. I tried to find $1, but I haven't used money in so long. We use credit cards, right, for everything. So we can have a piece of paper, or it can be digital, like the credit card. It works that way. Now, the interesting thing is this works out great. I can go down to the store. I can do what I need to do. But where it becomes interesting is if I want to buy a house or a car or something very complicated. When that happens, I need to get another party involved, the bank that you see here. And the bank shows that the money is not transferred directly from me to you because you may not trust me giving you that much money. So we go through a bank, and the bank guarantees a few things. It says, Buck really has that much money, and you are a real person that he really wants to send it to, and I will do all these things for you. And maybe you even use a different currency. Maybe I use dollars and you use lira, or a euro or a pound or something like that. And so the more people that get involved in that transaction, the slower it gets. Also, the more people are involved in our business. Also, they take a little bit of money. When the bank loans you a house, they have all these fees that they charge to loan you this money, or rather just transfer the money from one person to another. So this is a fiat currency, and that means because I said so. Well, some people came up with the idea, a very mysterious person actually. They're not even sure if it's a real person or if it's a group of people, but they came up with this white paper that talked about this concept called a blockchain. And on the blockchain, transfers of value could work like this. So let's take a look at how blockchain works. Well, first of all, it's a group of people. That's the first concept. It's centered around something called a ledger. And a ledger is a spreadsheet or a paper ledger like you're used to, like we've used for thousands of years. People have written things down in one column and another column. Money comes from here and it goes to there. Now, originally it wasn't even money, was it? It was bartering. I would take my loaf of bread and you would give me a hammer for 3 loaves of bread. Well, after a while, it got kind of cumbersome to carry around 3 loaves of bread. So I gave you a piece of paper that said, whenever you want your bread, I'll give you 3 loaves if you'll give me a hammer. And so they do. And that's the beginning of money. That's where that came from. So a ledger is very similar to that old bartering concept, if you think about it. Now, the interesting thing is no governments are involved here. The way this paper worked was we'll just get together, you and I, we'll agree to, I've got the resources and you've got what I want. And so I will send you this and we'll just write it down in a ledger. But here's the thing, I don't know you, and I don't know if you really have the hammer, and I don't know if you're really going to bring it to me on Thursday, and you don't know if I have 3 loaves of bread. So we need to come up with a system that other people verify we are who we are, that we have what we have, and that the transaction ever happened. And this is a network of people, and in Bitcoin, these are called miners, 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 people who actually apply algorithms and they compete for the chance to say, hey, Buck wants to send somebody some things of value. And they say, oh, I'll verify it. And they compete for that. And their computers do a very complex series of algorithms to verify that I was the sender, that the transaction happened, and that you got the transaction. At no point could I say, well, I never did that. I never sent him that money. And at no point could you say, well, he never sent me that money. I never got it, and so on. We would have a public record. And this is around that ledger. So we need to dig into that ledger, I think, a little bit more, because blockchain, the process, Bitcoin, works like this. Now, the interesting thing is this is all sort of built on trust. That's what this whole thing is kind of about. And so there are a lot of places where we have trust. Banks, when we go to the grocery store, we believe that when we open the jar of peanut butter we bought, it's peanut butter. We know that when somebody exports goods, we want to make sure it really left the port, it really got to, and the same thing that left what I did got to the place that I'm supposed to want. All right, so that's the blockchain process or Bitcoin. That's only one application of it, though. This idea of the ledger, this becomes very interesting. So let's take a look at this process, sort of in process. So I drink a lot of coffee. I don't know if you've noticed that about me, but I drink a lot of coffee. And I want to make sure this coffee I bought is really good coffee. And I like this idea of something called fair trade. And what that means is I want the people growing my coffee in another country to get the amount of money they should get. I don't want the big companies taking advantage of them. I don't want them to put poison on my plants. I want to make sure it's done organically. I want to make sure no one was harmed while they did this. This is something called a fair trade certification or an organic certification. So what could happen is, in the idea of a blockchain, if we're thinking about how this might work, the people that are farming could prove that they have the fair trade certification, and they could write that somewhere and say, I have this. The next line is the person that carries it, the person that goes and picks up the bags of coffee beans. I want to make sure they don't switch it out for some cheaper coffee and just say, yeah, I picked it up, it's good to go. So somebody verifies that that coffee that they picked up is really the coffee that's on the truck. And then somebody roasts the coffee. And I want to make sure when they roast the coffee, they roast it properly, that they're fair trade, that they didn't switch the coffee out. So they write things down as well. The person who distributes it, the next driver that takes it to the coffee shop, I want to make sure that they do what they do. They write it down. I want to make sure that the person that sells me the coffee is selling me the coffee I bought. And I want to be able to look at everything they've done. If you take a look, this is a chain of things that has happened. And every one of those things that happens gets added to a ledger. It gets added, and at various points, I can see every part of what happened. So that's interesting. But do you want to see this in real life? You can, let me do this. I'm going to move something out of the way here. There we go. And I'm going to pop up something that I think you'll find pretty interesting. If you go out to a very popular coffee store, you can find out right here, traceability.starbucks.com. You can actually scan the coffee that you just bought, whether you buy it in a bag or whether you buy it in a cup of coffee, and you can trace everywhere it went. In fact, they've actually got it on the web. You scan and you can see that this bag of coffee I bought here, this is the espresso roast because I like it really strong, started in Colombia, and I can see more of where it came from. I got it in Guatemala, Nicaragua, Colombia, and Brazil, and it's blends. And then it was roasted in Pennsylvania, and I can see exactly where it was roasted at, and I can see the details of all that. And then I can actually see the store that sold it to me, and I can see how they handled the coffee I got. This is blockchain. This is actually how that works. This is that very thing in real use, because I often get asked, is this just hype? Is this real? Is anybody really using this stuff? And they are. People really are using this stuff. All right, back to, I'm moving things around as you see me look away. All right, back to blockchain. All right, so we've got blockchain, the process, or Bitcoin is what we often think. And we'll actually come back to that here in a bit. We'll take a look at one of those. But there's also another part of blockchain. The blockchain is actually really math. Don't make that face. We're not going to do too much math today, but we've got to get into a little bit of math if that's okay. And there's various kinds of math that we need to understand. There's really two big parts that we need to understand about the math. So the first thing we need to understand is something called a hash. And if you have a computing science background, you already know all this. I don't remember things well, so I have to go look things up. And so I created a very, very simple example, which isn't accurate, but it helps illustrate what we're talking about here. All right, so a hash is something where I take a value. Well, let's just try one. Let's try one. So we'll take a base input. We'll just take the word buck. And we're going to apply an algorithm to it. What's an algorithm? That's a fancy name for math. We're just going to apply a math operation. All right. So we're going to perform some hashing on it. And what am I going to do? Well, most of us are familiar when we hit a letter on the keyboard. It's actually three numbers called ASCII, which stands for just the automatic way of encoding things we've typed, because the computer doesn't know what an A is. It only knows binary, and those binaries are converted to decimal, and the decimal is the value we see here. So the ASCII code, the keyboard code for BUCK is 0661170999107. And my very complicated algorithm is going to add the number 1. So 0 becomes 1, 6 becomes 7, 6 becomes 7, 1 becomes 2, and so on. And you can see when I got to a 9, I made it a 10, and the next one's a 10, and then so on. So I can now, and assuming nobody knows I did that, I could store that value, the hash, the one at the bottom in white, instead of the word buck, and prove that buck what was in there. It's a way of kind of signing it. In other words, if I were to say, what value do you have? And you say buck, and I put it into my hashing algorithm and I don't match, I could now say, wait a minute, I don't think that's accurate, or I do think it's accurate, because my stored hash signature is this number. And when I get the hash from you, I could tell if it's been touched. And that's very important for blockchain. Remember, we want to make sure that the coffee we bought is the coffee I got. So if each person signs with this hash, if they make up a number, now, by the way, that algorithm would never work because that's easy to find out, right? That would be easy to detect. Normally, the hashing algorithms are quite large and complicated, but we're using a very simple example here. So this idea is it's not encryption. This is not used to log in. This is not used as a password. This is a signature or sometimes called a fingerprint, and in some cases, it's even called a digest. Now, in my case, the 4 letters BUCK became a much longer number. But in many algorithms, hashing algorithms, you can take a large picture, which is just zeros and ones, as we all know, run special hashing algorithms, and it would become much smaller. That number that represents the picture or signs the picture as original would be much smaller. That's called a digest. But whether it's a digest, a fingerprint, or a signature, it's all just a hash. It's all just an algorithm that says this is the original number. Now, as you can imagine, this is only useful if I have the original hash stored somewhere safe where no one can mess with it. So we're going to come to that because it becomes a very base concept as we're talking about blockchain. So hopefully that helps you understand what a hash is. So that's pretty simple math. So far, you're not confused. So far, you're tracking. Everything's going well. Let's get a little more complicated. Not too much. We won't get too much complicated. Let's talk about now keys. Now we do need to talk about signing in and maybe encrypting data, changing data to where you could change it to where you don't know what it is. No one does until you apply that same algorithm or a different one to unencrypt it, right? So I've got Buck, I could encrypt it, and then no one knows what that is. And when I get it, I run my special key and up it pops and it says the word Buck. Now we're going to use a very, very oversimplified example. This isn't real. This would never work. You would never do this, but it'll get the concepts across. The first one we're all familiar with is a password. And this is something called a symmetric key. What does that mean? It only means that the same key that you use to lock the door to your house is the same key that you use to unlock the door to your house, right? You can lock it and you can unlock it. So here we go. Here's an overly simple example. So I've got a very complicated password. It's 123. That's the one I use all the time. 123. That's the password I use. Now this locks my data with an algorithm, and I've got a very, very, very simple algorithm. I'm going to take my value Buck, and I'm just going to multiply it. That's my complicated algorithm. I'm going to multiply it by the key. So the new number is 813-240-031-90161. All right, so it's like that. And so now if someone saw 813, what in the world does that mean? They would have no idea. Well, if you're very savvy and you're good and you're a good bad guy, you can absolutely figure it out. Oh, he just multiplied 123 to that. Computers can help you figure that out very quickly. This is not a very powerful algorithm. But for the general person, if I showed them 813 and I say, what do you think that is? They would never guess that the word Buck is that number, right? That's the way a symmetric key works. Now, the interesting thing is because I've done a multiplication, there's something called an inverse property. And we all learned this in school. Hopefully you remember that from your math. And an inverse property says that if you multiply something, you can divide it and get the original value. And so that's what we'll do. We'll just unlock it by taking the same number, 123, because it's a symmetric key. We'll divide it this time instead of multiply it, and now we'll get our original value back. That would be the ASCII value of Buck. And so that's how we encrypt something and decrypt something. Keep in mind, that could be used to log in or encrypt data. It could be done with lots of those kinds of things. Well, as you can imagine, this is a bit weak because of that inverse property alone, because that's what it's kind of depending on alone in this case. These algorithms, even there are various algorithms, the symmetric key algorithms, they're kind of easily broken. With enough intelligence and with enough hard work and big enough computer, you can break that. So it's not a very secure way to make sure the coffee I bought is the coffee I got, right? So it's not enough to make sure I encrypt all that data. What I really want is something a little stronger. And so we've got this idea of something called a public private key. Well, what is this? Well, this is slightly different. Now, most of you are probably way too young to remember this, but back in the early days of cars, when I used to drive in high school, if you went to a fancy restaurant, you had two sets of keys to your car. One key would open the door, the glove compartment, the trunk, all the doors, and would start the car and not start the car, right? It would turn it off. So they came up with this thing called a concierge key or a valet key. And what you would do with this, if you went to the fancy restaurant, they would park your car for you. But if you gave them your car keys, they could look in your trunk or your glove compartment or anything in your car. They could look at it all. We might not want them to do that. Not only that, what you'd like them to do is go park the car, and when they take the key out and lock the doors, they can't unlock the doors again. Nobody can. Only you with the other key. You've got two keys. So one key can lock the door, but another key is only used to unlock the door. So that's what's called a valet key. So we're going to get into this a little bit. We're going to go through some math here. Don't make that face. I'm going to give you a resource where you can go learn more about this. This has to do with something called material equivalence and a totient function. A totient function. Don't get me started. We'll go through here. All right. Number one, first step. And by the way, this is using RSA, which this hasn't been used for a while. It's considered easier to break, but it's also easier for me to explain. So in step one, we create two random prime numbers. And prime numbers are only divisible by themselves, and one, they don't factor out to anything else. And so they're not easy to divide or crack. And we don't know how far they go. It's believed they may be infinite. We're not sure. But they don't have a recurring pattern that you can kind of depend on. So we take these two random prime numbers, and we'll just call them P and Q. And we're going to make them fairly long, because if you get below 1024 bits, it's pretty easy to break them. So you want to make sure they're at least that big. They need to be pretty big numbers to do this. Second, we compute a new number. This is called a semi-prime, and it's computing the product of two randomly chosen prime numbers. So you've multiplied them against each other. This makes them very, very complicated at this point. All right, here we go. Next, we select an odd public exponent, something we're going to show people, between 3 and n minus 1 that is co-prime with the other two numbers. Oh my gosh, brain is breaking. It's okay. I'm going to show you a resource here in a minute. The little symbol with a 0 with the line through it, that's a totient. And it has to do with a certain mathematical property that these will hold. Once you've done that, I compute a private exponent, something I'm not going to show anybody else, from EP and Q, and where D is the multiplicative inverse of E. So I have a way to turn that lock backwards. That's the way this works. And it deals with modulo math and all the rest. Now what I can do is this. This is important. I can lock the data with my private key, meaning I could take Buck, run it through this algorithm, and Buck has now come up with this new number that is not 0611, and it's also very hard to break. However, I want you to know I have signed my email as me because I've given you the key that will only unlock. So you can only unlock. You can't encrypt anything with my data. You don't know how I did that, but you can unlock. Maybe I've got an email, or maybe I've got a bag of coffee beans that I want to encrypt the data with my private key, and anyone can look at that and say, yep, it came from Buck, but no one else could encrypt the data because my public key would not unencrypt their private key. So now they would say, well, that doesn't come from Buck because it doesn't work. That's that way. But you could reverse it. I could give you a key to encrypt the data, the public data, you could encrypt it and only I could unencrypt it. So now I could let you all send me a private message. All of you could encrypt it with exactly the same number, but you could never see anybody else's email because you don't have the key that unlocks it. So the nice thing about these keys is they're useful in two directions. All right, hashing and our public-private key. How does this work? What are we going to do? Well, what we're going to do is two things. We are going to hash the value to prove the source, and then we're going to sign that value with a key, a private key, so that we prove it was us that said that's the hash. That's what we're going to do. That's blockchain. That's what goes inside the ledger. Now, if you are, by the way, let me pop this up out of the way again. I apologize. The screens tend to step on each other here a little bit. But if you'd like to see that, you can actually go see how RSA works. And this gentleman does a great job of walking through every part of the mathematics. If you are interested in modulo math and multiplicative inverses, if you have no life like me, and you want to know these things and you want to get Euler's totient and you want to see how you do the key generation and large prime generation, you have that available to you. All right, so that is there is the math out there. So how does all this work together to make a blockchain? So I know there's hashing and I know there's the signature. So how does that work together to make the blockchain? What does a ledger sort of look like? Well, let's take a look at what one looks like. Now, let me show you the process that you would use. One of the things you could do inside blockchain is that you could use the rows themselves, the actual row in a table or a spreadsheet or a ledger, to create your hash. Then you could hash the hashes and hash those and go all the way up to a final value that proves all of the columns in that row of data were added together, the hash of them, to make a new hash called the H root. It's very odd, but this is what would go in the ledger. All right. Well, this is very interesting. When we start thinking about this, we've already seen coffee as an example. Well, what about other examples? Are there other places we could use to prove that this table has not been messed with, that nobody has touched this ledger except the people that were supposed to? Well, there's quite a bit, actually. The ledger part of blockchain, just the ledger now. We're not talking about the math part or Bitcoin. We're just talking about that ledger at this point. One of the things you could do is you could make sure, if you do an audit, if I could just look and I know the hashes, they've been signed and they're hash, and the hash matches what I've got somewhere else, I don't have to audit anything, because if it had changed, you'd see it just like that. If somebody altered the bag of coffee on the way and an IoT device is scanning that and it's creating the hash and the hashes don't match, you could tell not only that the bag has been messed with, you could tell exactly where it was messed with in the chain of things so that you could see how things go. Well, there's other places this could be used. You could enable things between each other. Now blockchains are actually public. You can see them. The ones that you've heard of, Ethereum and some of the others, you can actually see those. You can actually see those transactions. Well, you may not want that. I want to allow people to check, but I only want one company to another, or maybe even just in my own company. And I want to trust you, but I want to make sure that I can trust you, right? Another place you could use a ledger is to verify that a database hasn't been messed with, and that's going to bring us to our next concept here. And by the way, there are a lot of places, real world. I keep having to move this screen out of the way. I apologize. Let me see if I can put it over here and get it completely out of the way. There we go. One of the places, let me look here and get my resource that you may want to see. Most of us are dealing with COVID right now, are we not? We're all sort of dealing with COVID. Well, a while back, back in April, there was a place in let me see where this was, in Baltimore, Maryland, in the United States, that had 62 million doses of the vaccine that had to be thrown out. How would you like to make that phone call? How would you like to be the person that has to say, oh, we had a bit of an issue. And you make that phone call and say, we got to get rid of 62. And this is back when things were burning bright. They popped back up again, of course. But imagine having to throw out life-saving things because they couldn't tell which one had been broken. They didn't know where the particular problem was. So all of it was suspect because you certainly don't want to give someone something that doesn't work. Well, here was a real place that you should have been using blockchain, right? Or at least the ledger of blockchain. So that's what we're talking about. First, blockchain equals Bitcoin. True, but not completely true. Blockchain is lots of parts. It's the Bitcoin itself, which is just the unit of value we've agreed on. It is the ability to track everything in the ledger, and then it's the ability to prove that tracking, the math. All right, having said all that, let's take now our scenario. Remember our scenario here? Let's walk this through on a blockchain. Okay, so you saw the Starbucks page that showed each person doing each thing. How did it do that? Here's the magic. This took me a long time to build because I had to understand it myself. Number one, when the fair trade person that grew the coffee puts it in a bag, they have the ability to stamp on it, this is fair trade coffee. I have a certificate with a number on it that says I follow the processes. And people come inspect me, and the government comes by, and everybody comes and looks at my stuff, and I prove that I have that. So they have that data, their certificate, which they encrypt. They have the hash of that encryption, and then they sign it with their private key. There we go. There's your math. We have it. That's called a block. They then move out, in the case of a public blockchain, to the blockchain system around the world and say, I would like to add this transaction that just happened. I just made a bag of coffee. It's got a number. You can track it with the barcode from now on. That's a block. That's what that's called. So they asked to be put on the blockchain. There's a group of people called miners who have a bunch of math systems that they do, that they prove that you're trustworthy and that's a bag of coffee and all that, and they do that mathematically. They add their data and their hash and their signature, and then they add your block to the block that came before it. And they add another block, and they add another block, and it makes a chain. And that's why it's called a blockchain. So same thing, the carrier goes, hey, we've been inspected. I verified, I've got a camera of the lady that took it off the truck and the guy that put it on this truck and so on. So they add their data and their hash and their signature, and they say, hey, we want to put that on the blockchain. Same thing happens. The same group of people or a different one competes to say, I'll do the math. They get paid a little tiny bit of money to do that for each one of these that they do. And they put it on the blockchain and they add it to the end. And there's a ledger you can see there, and you can look at it anytime you want. And as each of these steps happen, each of these people start asking, can I put my block on the blockchain? Can I put my block on the blockchain? Can I put my block on the blockchain? Can I put my block? Would you like to see one? You can look at them. They're public. Let me pop open our resource here again. And I'm just going to go to blockchain.com, blocks/blocks. And when I look at the blocks, there they are. You're watching blockchain happen real time. 10 minutes ago, via BTC did this, and it was this size. There's the hash that proves that happened. That hash got put on the blockchain. Let's take a look at what's inside. Here's one that's about 14K long. Let me click on this one, and you can look at this anytime you want. This block was mined on 14 August 2021 by Unknown. If you click on Unknown, it'll take you to their hash and so on. It has 35 confirmations. The miner earned a reward of 6.255 Bitcoins. The reward consisted of a base word and so on. Here was the address that it came from and to. There's the hash they made. There's the numbers. There's the timestamp. There's how much data was in there. There's the miner. It says unknown, but you can click on it and actually find out more information. There were 47 transactions, 47 blocks in this one. It was this hard to do. And then we get to this. What in the world is a Merkle root? What is that? Oh, you know what? You've actually already seen a Merkle root. That's that. That's a Merkle root, by the way. So you've actually already seen this. Let me zip back to where we were here. There goes the blockchain. Now let's go look at our thing. See how it all comes together? The math and the hash makes the Merkle root. And the Merkle root is done by adding the hashes below to the hashes above to signify a hash of hashes. And that's the Merkle root that you see there that happened. This is the version. That's how many bits. Size. A nonce is a guarantee that it only happens one time like this. There's no clashes. That happens that way. A nonce, if you're not familiar with those, check that out inside your computer science degree programs. It'll tell you how it works. And here's the different block transactions right there. Tells you where it went from and to. You can even click on that and you can see who did what, what's included in the block, the little output, the inputs, the witness, the address, the index, and everything else that you can see. So it's a very open system. Well, maybe you want that, and maybe you don't. Maybe you want those advantages. Maybe Johnson & Johnson does want to track their drugs throughout the cycle, just like Starbucks did, but they don't want everybody to know they're doing that. They don't want them to be able to look at it. In some cases, you do. If I'm going to send money to David, I want to make sure that David can't say, I never sent that money. I want to make sure that's not true. I want to make sure I can prove to everyone, hey, everybody look, he did that. But if I'm in a company, maybe I don't want to do that. So what we've seen is blockchain, the process, Bitcoin. And you can see how this works now. The coin, by the way, just made up. You could make your own if you want. And if people start using it, it works. If people don't use it, it doesn't work. That's how currency is. It's just literally trust. The real meat here is the ledger. And the real meat of the ledger is the math that went into the ledger, which you've now seen. So now let's get to what SQL Server and Microsoft is doing with the technology of blockchain. So SQL Ledger isn't blockchain. You could make a blockchain if you wanted. It has a blockchain in it because it's got the Merkle tree algorithms and so on, but it's not Bitcoin. You're not going to mine Bitcoin in SQL Server. That's not what it's for. What is it for? Well, we'll come to that. I'll explain more about where you would use this. Let's talk about the way we're doing this to begin with. So what does SQL have? Well, inside Azure SQL Database Ledger, long title there, you get the idea of a blockchain. You get an actual blockchain, but you get the ledger, and it basically makes it tamper evident. That's important. The data is not immutable. What does immutable mean? Immutable means it can't be changed. And there are very few immutable systems. Almost everything can be changed. So rather than say, we're just never going to let anybody touch this, it would actually be better if I could prove you touched it, right? So one of the things when I deal with security, I'm going to pop up a very strange tool here for you. That's kind of interesting. You may have seen this before. This is let me zoom in here if I can. This is the event viewer in Windows. And you've got these logs in Windows, right? And one of those is called security. And you can see I've got a bunch of things in my security log. Those audit failures are me, by the way, just so you know. But watch this. I'm a bad guy, and one of the first things I want to do is cover my tracks. So this log is here, and I want to erase it. Now, Buck, has been saving my log off from time to time, but I want to make sure nobody has touched this. Well, this bad guy basically comes in here and says, well, I've gotten your system. So the first thing I'm going to do is make sure you can't see I got your system. And it's going to say, I'm going to clear the log here. So let me do this. And I'm just going to right click and clear the log. And immediately it says, you can save this. And I'm the bad guy. So I'm going to say, no, I'm good. I don't need to save it. And empty it goes. However, no matter how many times the bad guy does that, it still says the audit log was cleared. There will always be at least one entry that says that happened. That is exactly what we're talking about right here. Tamper evident. If I ever see that, in fact, I scrubbed for that all day. The log was cleared. What? And then I go pull my backup of the log to see what was happening just before that happened, right? So we want to make sure that that's not the bad guy. Okay, so it provides a tamper evident. We're going to see how it does that in just a minute. The next thing it does is it provides a historical record of all changes. And you say, wait a minute, you already have that. You have something called temporal tables. It already does that. It does, but this is verified just like a blockchain is. We use a Merkle tree and we put the hash and the signatures in there. We're going to see how we can check those in just a moment. But it's just SQL. It's just regular old SQL. You don't have to do anything special. So the first thing you do to make this work is you just go create a SQL database. And when you create it, you click the security tab and you can see there the word create ledger. So you click that, you just click the ledger. When you do that, a new feature comes up. Now keep in mind, if you enable ledger for a database, all the tables are covered by the ledger. No one can change that. That's the way that is from now on. Now, I want to bring up a very interesting point right here. Keep in mind, we talked about the idea of being able to check the hash. Well, that checking of the hash has to be put somewhere else. If I put it in the database, just like the bad guy cleared the Windows event log, I could go clear the SQL system and you wouldn't know I'd changed it. And I put some new data in there and now we're good to go. And so I want to make sure that I keep a copy of those hashes somewhere else. I have a couple of choices. First is Azure Storage, where you could come up with your own way of securing it. Another is something called Azure Confidential Ledger, which is not in SQL Server, but it's tied to only your account and your login. Even Microsoft can't see what's in Azure Confidential Ledger. That's yours, but it keeps a track. All right. Now we move forward. How do we do this? By the way, you do want an immutable policy in the ledger backup. You do want to make sure nobody changes that because you want to be able to compare it just like we did earlier. All right, here's what we're going to do. We're just going to make a fake banking schema. We're going to turn ledger on. That's all done with Transact SQL. No harm, no foul. Easy to do. Then we're going to say, by the way, we can have, there's two types. There's an updatable table, which is like a regular table where you can update, insert, delete, and so on. And one that says, no, this is update only. And that means the ledger tables can only be added to. They can never be deleted from. We just don't let you delete from that operation. And there's reasons to do both. It's in our documentation. All right, here we go. Let's do an insert into. Let's create a table. We did that. We're going to insert into, and we're going to give Nick Jones $50. We're going to give him 50 US dollars. We're going to put it in there. Notice that because ledger is turned on, there's some new columns. See, there's the transaction ID and the end transaction ID and a sequence number. These are where our hashes and signatures are going to come into place. All right. So no big deal there. It's given its own transaction idea. And then we're going to add some more data. We're going to add John, Joe, and Mary with some more inserts. And we're going to give them different money, a little more or a little less than we give Nick. And so that's what the database looks like now. So easy peasy. But what's happened is this. There is a ledger sequence number. Aha. So now we see that those things happen, just like the Starbucks truck, just like the stuff we saw on the blockchain. That's what you're doing here. Now, when we see the table itself, we see the table itself is now $100. We give him $50 more, and it's $100. But the previous row has now been copied. We still have $50 showing in the original ledger view. So now I can see exactly what happened here. And if somebody tries to do a little sleight of hand, I can prove that it's wrong. Here's how I can prove that it's wrong. I can go get wherever I put my ledger, and I can read it in SQL Server, and I can say, compare the ledger entries to the ledger entries that I have in SQL Server. make sure out on storage, that hash equals this hash. That's the ledger part. That's the blockchain part. This one came back and says, yep, nobody's tampered anything. They look the same to me. But if they had tampered with something, this will come back with a failure and show you what happened. So we can go get wherever we put our path inside our codes. All this can be done inside Transact SQL. I've actually got a lot of places where I've put this. You can put it in different locations. We talked about that. You have control, or you just give it over to a system where it's done. Now, at the end, you want to make sure the database itself has not been tampered with. So we give you some Transact SQL that you can just copy and run this over and over whenever you like. And this will give you your digest that says if it's not been messed with, say it's current. And if it's been messed with, say false. And then we can come back there. All right, who's using this stuff? Is it all hype? No, it's not all hype. We've got BP using it. We've got Avanade. We've got RTGS Global. We've got lots of folks that are using it, and you can see kind of where that is. All right, I'm going to end up on a resources slide so you can screenshot this if you wish. And then I'm going to go see if I can figure out the interface here, if I can view the chat here. Let me see if there's a, no, that's not that. I don't use WebEx very often. My apologies. Let's see, let me go to that view and see if there's a, no.
We have anyway added this to the page, event page, and we'll also add this one, whichever is missing on the page. So anyone can go there and directly they can get all the details from there.
Right. Okay, what I'm going to do here, I'm not able to see the chat window for whatever reason. So I'm going to leave this up just for a moment and let you screenshot it, and then I'm going to turn that off and just share my video because I know I can get to the chat there just in case there's questions in the last 4 or 5 minutes here. So I'm going to go ahead and stop sharing. Let me do this. Stop sharing. There it is. Apologies again, I don't use this very often. Okay, so we've got some questions down here. Let me just pop up the chat link and see if there was anything that was happening. I couldn't see it while I was talking. Let's see. It's better now. Hi guys. What is the purpose of these courses? Can you complete intro fast to understand? Okay. And so on. Can you share the PowerPoint? I will send that to the multi-cloud folks. And they will be able there. That's great. Certificate, FAQ, what's the code? Will not for the code. All the links on the page will get you those. Okay. The question we have here is, does Bitcoin have to be distributed? Yes, that's its nature. Bitcoin has to be distributed. The ledger does not. But the Bitcoin product, the one that's copyrighted Bitcoin, it starts with the idea that it is in fact distributed. That's the whole point. That's who's verifying that you are who you are, I am who I am, I have what I have, you have what you have, and we made a transaction. So that's how that works. So the distribution nature. I think the question may be, does it need to be publicly distributed? Yes, for Bitcoin, but you could use SQL Ledger and build your own process to do this between companies. By the way, those are called a smart contract, allowing you to do that. Does a SQL Ledger support failover group or geo-replication? So it's built inside of Azure SQL, so you get the same thing in Azure SQL. What you'd want to be careful about is making sure your digest is copied as well. There's a GitHub link. You can ask questions. Let's see. Ledger on, is it available only in Azure SQL or on Prem DB as well? Great question. We get asked this a lot. At the moment, this is an Azure feature. We've always had the idea that we're going to try and bring everything together all the time, but there's always reasons that you need to do that or don't. So at the moment, this is an Azure feature for Azure SQL DB. It also lends itself very well. It's easy to turn on and off, so developers love it up in the cloud is the way this works. Okay, we are at time here. What are the different types of tables in SQL Ledger? in the documentation that's on those links that you had the screenshot for, you'll see all of the differences between regular SQL and Azure and the Ledger. It's not that different. So certain things, of course, certain fields are going to be harder to hash and so on. So those might be a little different. But there is a full list of the compatibility table for that there. Okay, I think we've drained the questions. So we're going to turn it back over to the hosts. I really appreciate being able to be with you here today. And I'm going to cut my video off and turn it back to you guys.
Yeah, you can keep your video on. Right? No issues.
Okay.
Any questions you still need to ask to, or if you need to talk to Buck, just let me know. I will keep your I will unmute you. And everything is there on the site. I will again reshare my screen and try to show you where you can take the exam, take the certificate, everything, which is everything there. So just give me a moment. So I believe you are able to see my screen.
Yes.
Just have to go to fifthir.com/Buck, and all the content that Buck is suggesting and given us today will be here, available here. And you see the event is already being streamed here. It's already live, and
yes,
we're already seeing here. And then here you see this is the source code to download. This takes to the GitHub library, which is where this is all the documentation for SQL Ledger is there. You see here video. There's extra video, which is like there are multiple discussions that happen on SQL Ledger from Microsoft folks like Jason, Anna, and all other are here. Then there is a file which is more around this text to you to the announcement, which is there around tech community. So, and this has the white paper link also that Buck was talking about, right, Buck? This has the white paper link, right?
That's right.
Yeah, and then this is the FAQ. Once you click it out, it will take you to an exam page where you can take that 5-question exam. Once the exam is done, you will get the result here on the fly, and you will also get your certificate attached here, which is one free certificate. Instead of claim, it should say download within 4 or 5 minutes, and you will also get into your email. So from here you can see, and also whenever you come back, you can see your courses and certificate. Here also it will be attached in this area. So thank you, Buck, for your time today, especially on weekend. And obviously everyone would have enjoyed the session. Do give us feedback, and so that we can pass it to Buck. And thank you everyone for joining the session today. We have another one on 29th of August, which is around 10 top tips for solution architects, which is like latest and greatest in microservice architecture and all. We'll have Ankur Kumar, who is a very well-known blogger and an practicing architect, director of technology in Publicis Sapient, and he handles a lot of different clients. He is most like a Java expert, will be joining us. And then we'll have Preeti Harman in February, in September. She will be talking on Azure Purview, which is another big great session is going to happen in the data world. And that's how we continue. We'll keep you updated through our calendar. You can anytime go to calendar and then find out all the events, or directly go to events. You will see different events coming up here. So you see that this event has gone, and the next event is already been showing up. So thank you everybody again. And if you have any issues, you can connect to our Telegram channel. It's always there, and you can join, or you can connect to this help center to find any help from us. Thank you, Buck.
Thanks again. Bye-bye.
Bye.
Bye.